Okay, so we have the warm-up. Find the following limit. The limit as x approaches infinity of this function. Let's do it the quick way, where we say that as it approaches infinity, 1 becomes insignificant. And so we're going to have that square root of x squared is equal to x for values that are greater than or equal to 0. And it is approaching infinity. Okay? So we're just going to say it is x. So then this is x minus x will give us 0. So we're saying that the answer is 0 by doing the shortcut way. Let's do it using the multiplying by the conjugate. See what we get. Square root of x squared plus 1 plus x, and then we write the same thing on the bottom. Okay. The top, we know the middle is going to cancel out when you multiply it out, so it's going to be the limit as x approaches infinity of x squared plus 1, and then negative x times positive x is negative x squared, and then we have our x squared plus 1 plus x as it approaches infinity. Okay, so the top x squared minus x cancels out. What could we do here? Well, again, we can go ahead and say that the limit as x approaches infinity of 1 over, again, let's do this thing. Well, we're still using that idea though. So this is going to become x plus x this time though. And so we're going to have limit as x approaches infinity of 1 over 2x. But then again, x approaches infinity, this becomes really big, even multiplied by 2. So this becomes really super big. So 1 over a really big number is 0. So both do have an answer of 0. And I'm going to say that the answer is 0. So these are kind of tricky questions. Maybe you want to do it both ways just to verify that the same answers, you're getting the same, doing it both ways. Last lesson of chapter 1.16, unit 1, the intermediate value theorem. Okay, so what is the intermediate value theorem? So this is like a summary of everything we've done, and that hopefully you do understand continuity and the definition of continuity. So it summarizes everything. So here's what it says, the intermediate value theorem. Suppose that f is continuous on the closed interval AB. So suppose that f, this is f, this blue curve, on the interval AB, where it is defined at A, defined at B. So defined at A, defined at B, in continuous. Now let n be any number between f of A and f of B. So let n be a number here that is between f of A and f of B. Then there must exist a number C in A and B between here on this interval such that f of C is equal to n. So this is f of C. There has to be some f of C that there's an output n in between A and B, between A and B. That's just what the definition, that's what it says. how can we put this into something tangible, something that makes sense, something in real life? Let me give you an example. Let me give you a quick example in real life. Say this is your age, okay, and then this is your height. So you go straight up. Your height, let's say, is linear. So at say 2 years old, you're, I don't know, how tall could you be? I don't know, 4 feet? So this is in feet? You can't be that tall. Maybe you could, but I don't know. Let's make up another, let's go with 2 feet. I don't know. 24 inches, could you? All right. That's in feet. And let's say this one is right now. You're like, what, 16 years old? How tall are you now? In feet? You're tall. Let's say you're 6 feet. Okay. All this is saying that suppose that f is continuous. F is this linear function on A and on AB, and let n be any number between f of A and f of B. So let's say this n is this right here. This is n, and let n be a number between 6 and 2. So let's go with 3.5. All right. I mean, could have gone with 4 better. Let's go with 4 feet. Let n be any number between f of A and f of B. Then there exists a number c in between A and B that's such that f of c is equal to n. There must have, all this is saying that f of, at some time, this is year, no? There was a time where you were exactly 4 feet tall. Of course you were. If it's continuous. So at some time you were two feet tall, then you were 6 feet tall. You are 6 feet tall now. You're really tall. At some point you had to have been 4 foot. When was it? What, when you were like 12 or something, whatever? So basically, I mean, it's very, I think that's the idea of this intermediate value theorem, that at every point, at every year, you were some kind of tall. Maybe at 3 years old, you were that tall. At 4, you were that. At 5, all like that. It's not like you died and came back to life or anything like that. So you're defined to be, and it's continuous. Okay, so that's the idea of this. Question 1. Below is the table of values for a continuous function f. The big thing to understand is continuous. So x, for these values of x, 0, 3, 4, 8, 9, you got these outputs. And it says that on the interval from x is greater than or equal to 0 and less than or equal to 9, what is the minimum number of zeros? What does it mean by the minimum number of zeros? It's just saying how many times does it cross the x-axis. So what you could do whenever you're getting something like this is just kind of do a rough sketch of what's happening here. Make a graph. So at x equal to 0, time equal to 0, x equal to 0, you're at 1. At 3, you're at -5. At 4, you're at 3. 8, you're at 7, and then 9, you're at -1. And so continuity that is continuous means that, you know, what was that definition, continuous? That you can draw a curve without lifting your pencil. So it's continuous. Okay. So now let's answer this question. What is the minimum number of zeros? So between here and here, it had to have crossed to get to this point, because the f of 0 is positive and f of 3 is negative. So it must have crossed at least one time to get to the other side. Basically, almost like the chicken crossed to the other side. It must have crossed 0. We could have done it many more times, but we don't have any information about what it did in between. But for sure, it crossed one time. And then you got 4 went to 3. So here, and again, it must have crossed sometime at least once there. And then going back, so whenever it changes signs, the number of times it changes signs is going to be it. So change signs there. And then it changed signs all the way here. So 2 times, would that be 2 times? No, there's another one here. So there's 3 times. So 3 is the minimum number of zeros that is guaranteed by that IVT, intermediate value theorem. On the interval from 4 to 9, what is the fewest possible times that f of x is equal to 1? Fewest number of times that f of x is equal to 1 between 4 and 9. So 1, 2, 3, 4, and 9. What's the fewest possible numbers of f of x is equal to 1? Well, draw a line across here. So it's going to be 1, 2. So it must there's 2. 1 time is the least that is guaranteed by the IVT. On the interval from 4 to 9, 4 to 9. Let's see, 4 to 9. Okay, so I got that one wrong. And 4 to 9 is very important to know where you're coming from. See, we're saying from 4, 1, 2, 3, 4. This is 3. 3. And then we got 8 go to 7. 7 is over here somewhere. And you got 9 is negative 1. So we're right here. We're looking at this is 3. And this is negative 1. So 1 is correct, because that's the only time that it could have crossed 1. So you got to be very careful in looking at all the numbers correctly. So on the interval 3 to 4, must there be a value of x for which f of x is equal to 2? Let's see, from 3 to 4. So is 2 between negative 5 and 3? Yes, yes it is. Yes, on the interval from x greater than or equal to 3, less than or equal to 4, f of x equal to 2 because of that intermediate value theorem. It is between f of 3 and f of 4. On the interval x greater than or equal to 4, less than or equal to 8, could there be a value of x for which f of x is negative 2? From 4 to 8, 4 to 8. Let's see, from 4 to 8. So the output is 3 for 4, the output is 7 for 8. Is negative 2 between 3 and 7? No, it's not. So it's not guaranteed. Let's see, it could, but it's not guaranteed. Okay, use the intermediate value theorem to show that there is a root of the given equation in the specified interval. Problem 2. So, is there a root? And when it says root, again, it does have a 0. So, on this interval, the way I'm going to do this is kind of move everything to one side, either the left or the right, and just evaluate f of 0 and evaluate f of 3. If f of 0 gives you some positive number, say positive, and this one gives you a negative number, then it would be, when there's a change of signs, no? So if this is then is negative and this is positive, then also it would happen. it would have that, it does have a root. But if it happens that it is like this, no, we got what f of, it becomes a positive and a positive, you can't guarantee it, and if it's a minus and a minus, you can't guarantee it. So that's what the idea is. So let's move everything to the right by adding 2 square root of x plus 5. Cancel that. And now just evaluate f of 0 and f of 3. So f of 0 is 5. F of 3 is this negative number. So since there was a change of signs, there is a root. There must be a root between them. Since 0 is greater than negative 270.5 but less than 5, by the intermediate value theorem, there is a solution between 0 and 3. So we'll do this the same way as we did the other one. Move everything to one side. Evaluate f of 0. Does it have a change of sign when you do f of pi? F of pi. There again, there is a change of signs. So 0 is greater than negative 1, less than 6.9. By the intermediate value theorem, there is a solution between 0 and pi. Number 4. Consider the function s of x equals that. There must be some a between 0 and 1 for which s of a equal to 3. Does the intermediate value theorem apply? Explain your reasoning. So they have this statement. Consider the function. This is a quadratic function which is continuous on its domain. This is continuous. Continuous. There must be some a between 0 and 1 for which s of a equals 3. Does the IVT apply? Yes. And so now all we got to do is find s of 0. And we're saying that for some a, it is equal to 3. And then we want to test s of s of 1. All right. So we have s of 0. S of 0 is 0. If you plug it in. And then we got s of 1 is 6, because you plug it in, it'll be 6. So is 3 between 0 and 6? Yes, it is, because it is a continuous function. The intermediate value theorem applied, and there must be some a between 0 and 1 for which s of a is 3. Okay, see you next time. We're done.